Hello and welcome back to Chapter 9. If you recall, before spring break we were talking about Section 9.3, which dealt with geometric series and sequences. This is going to be the second part of that video. And specifically we're going to look at the geometric sequence portion. So if we want to, let's go ahead and look at the sum of a finite geometric sequence. It says that the sum of a geometric sequence, and if you recall, a sequence looks something like a sub 1. You have your a sub 1 times your common ratio, which is what the r is. You have your a sub 1 times your common ratio squared, your first term times your ratio to the third power, and so on. This is what makes up our sequence. If we want to, and this here should be ratio, not ration. If you want to add or sum all of those up, okay, we have an equation that says if you take your first term, a sub 1, and multiply it by 1 minus that common ratio raised to the power of n, divided by 1 minus your common ratio, that is the same thing as adding up all of those individual all of those individual numbers. So let's go ahead and look at example 6. Remember, this is part 2, and go from there. It says, find the sum of 2 raised to the n minus 1, and we're going to be starting at the first term and going up to the 7th term. So if you recall, the formula said that in order to find the sum of n terms, we need to, and this is where I equals 1 to 7 of 2 to the n minus 1. The first thing we need to do is we need to find the first term, or a sub 1, and multiply it by 1 minus our common ratio r raised to the power of n divided by 1 minus that common ratio r. So the first thing we need to do is we need to identify everything. We need to know what our first term is. We need to know what our ratio is, and then we also need to find our number n. So to find our first term, or a sub 1 term, a sub 1 is really equal to 2 to the 1 minus 1, which is equal to 2 to the power of 0, which is equal to 1. Our ratio, r, is 2, and our value n, which is given up here, is equal to 7. So now that I have each piece, I can take all of this and plug it into this equation. So a sub 1 is 1 times the quantity of 1 minus 2 to the 7th power divided by 1 minus 2. When I simplify this, I'm going to ignore the 1 because 1 times anything is that anything. So I'm just going to focus on simplifying the stuff inside the parentheses. So I end up with 1 minus 2 to the 7th, which is 1 minus 128, divided by 1 minus 2, which is a negative 1. So I end up with a negative 127 divided by a negative 1, which is really equal to a positive 127. So if you were to take and find each individual term, go 2 to the n, or 1 minus 1, 2 to the 2 minus 1, 2 to the 3 minus 1, all the way up to the 7th, the value of n for equals 7, you would find that adding all those individual terms up gives you 127. So I would hope that you would agree that this formula here is actually simpler to use. Now the only thing that we have to be careful with when using this formula is that when you use that formula, you have to make sure that the sum is of this form. Is of this form right here. Now pay attention, that I is actually starting out at 1 and it's going up to n. Sometimes if you've noticed in some of your problems, it might not start out at 1, it might start out at a different number. And if it starts out at a different number, then all we're going to have to do is we're going to have to adjust the formula so that we start out at 1, but that might also mean that we have to adjust this n value as well. So let's just look at a quick example. if you're given something that tells you that we want to find the sum when I equals 0 to 12 of 4 times 0.3, that's a 0.3 to the power of t, okay, because this right here does not start out at I equals 1, I'm going to have to adjust that. Now to adjust that, all I'm going to do is I'm going to say I equals 1, so I had to add 1 to this 0 here, which means I also have to add 1 to my n value. So I'm really going from 1 to 13 then. And then everything else is going to be the same. And then I could go ahead and use the formula given right here. The next thing we're going to look at is the sum of an infinite geometric series. Now, this only works if you can take your R value, and we only want to look at the value itself. I don't care if it's positive or negative, but if you take the absolute value of that R value and it's less than 1, then the infinite geometric series, okay, given right here, okay, has a sum that is equal to, now notice here we're starting out at I equals 0 and we're going to infinity. Okay, I'm going to take my first term and I'm going to divide it by 1 minus my R, or my constant ratio. Now, if that R value is greater than 1, then the series does not have a sum. So you do have to pay attention to what your R value is. Now looking at example 7, part A says find each sum. And we're looking at n equals 0 to infinity of 5 times 1/2 raised to the power of n. So if I look at this right here, I see that I have I'm starting out with my n equals 0. I'm going up to infinity like I should. My R value, which is right here, and maybe we should write this down. R is equal to 1/2. 1/2 is less than 1, so that tells me that I can go ahead and find the sum. And if you recall, the sum was equal to your first term, or a sub 1, divided by 1 minus R. So I'll have to go through and I'll have to find my first term, or a sub 1, and I'm going to find that by going 5 times 1/2 raised to the power of 0. Okay, and that's going to give me 5. Anything raised to the power of 0 is 1, so 5 times 1 is 5. Now, I know my a sub 1 term. I know that R was equal to 1/2 because I have that down here. So now I can go ahead and find my sum is equal to 5 divided by 1 minus 1/2, which is really 5 divided by 1/2, which is really equal to 10. So the sum, as I approach infinity, of this function here is going to approach 10. Now for part B, I'm going to still use the same equation that I did up above, and I know that right here, this 5 here is really my a sub 1 term. Now the only thing I'm missing out of this equation is my R value, and your R value can be found by dividing out two sequential terms. So I'm just going to pick 2 here, and I'm going to go 0.5 divided by 5, and I see that that gives me 0.1, and you can take any of those terms out and you'll get the same thing. So now that I know my first term and I know my R value, I can go ahead and find the sum. So my sum is equal to my a sub 1 value, which was 5, divided by 1 minus 0.1, which is going to give me 5 divided by 0.9, and if you can convert that, that's really going to give you 50/9. So this would be the sum that series is approaching. Now, for your fun fact for today, and this is coming from timmystutor.com, it says, it is impossible, and you can test this out and let me know how it goes. It is impossible to sneeze with your eyes open. So test it out. Let me know how it goes, and we'll see if we can prove this or not. Have a good day. Bye.